if 5.3 times 10 to the power 6 plus a times 10 to the power 5 divided by 3.2 times 10 to the power of minus 3 is equal to 2 times 10 to the power 9, find the value of a, and a is an element of or, the real number set. So what I have here is basically a solving question. I want to solve for a. I want to get the a in its own. And I have a fraction on the left hand side and I have a number on the right hand side. So what I want to do is make the left hand side and the right hand side fractions, and then I can cross multiply and solve for a. So I'm going to put 2 times 10 to the power of 9 over 1 and cross multiply to get a times 10 to the power of 5 on its own. So I put 2 times 10 to the power of 9 over 1 and I cross multiply. So my numerator on my left hand side is going to be multiplied by 1. So we end up with 5.3 times 10 to the power 6 plus a times 10 to the power 5 multiplied by 1. Then I bring down my equals. And then my denominator on my left hand side is going to be multiplied by my numerator on the right hand side. So it's going to be 3.12 times 10 to the power of minus 3 multiplied by 2 times 10 to the power of 9. So 5.3 times 10 to the power 6 plus a times 10 to the power 5 multiplied by 1 is just going to give me the same thing. 5.3 times 10 to the power 6 plus a times 10 to the power 5. I bring down the equals. Then on the right hand side, I'm multiplying the decimals by each other. So 3.12 multiplied by 2 gives me 6.24. So 3.12 times 2 gives me 6.24. And then I'm going to multiply the 10 to the power of minus 3 by the 10 to the power of 9. So I'm multiplying powers with the same base. I'm going to add the powers. So that's one of my laws of indices. And that is law number 1 of indices. A to the power of p times a to the power of q is going to give me a to the power of p plus q. So multiplying powers with the same base, I add the powers. So 10 to the power of minus 3 multiplied by 10 to the power of 9 is going to give me 10 to the power of minus 3 plus 9, which will give me 10 to the power of 6. So that's where that 10 to the power of 6 comes from. So 3.12 times 2 gives me 6.24. 10 to the power of minus 3 times 10 to the power of 9 gives me 10 to the power of 6. So my goal is to solve, to find the value of a. So I need to get the a in its own. So what I'm going to do in my next step is bring the 5.3 times 10 to the power of 6 over the other side of the equals, and it was originally a positive, so now it becomes a negative. So I bring down the a times 10 to the power of 5 down here. I bring down the equals. I still have the 6.24 times 10 to the power of 6, and now I have minus 5.3 times 10 to the power of 6. Now when I'm adding or subtracting numbers that are in scientific notation form, I have to make sure that I have the same base 10. In this case I already do. I have 6.24 times 10 to the power of 6 and 5.3 times 10 to the power of 6. So I can just subtract them straight away. I can take out the highest common factor, which is the 10 to the power of 6, and just subtract the numbers. But if these powers were different, I would have to rewrite one of them so that they matched up. But in this case they're already the same. So 6.24 minus 5.3 is going to give me 0.94. So that's where that 0.94 comes from. And then I just bring down the highest common factor, which is the 10 to the power of 6. So on the left hand side, I now have a times 10 to the power of 5 equals 0.94 times 10 to the power of 6. Now at this point, I would like to have 10 to the power of 6 to be matching up with the 10 to the power of 5. Because if I do have that, then I can just cancel out the 10 to the power of 5s, and I will just be left with the a on the left of the equal sign equal to the answer on the right. So if I want to change this 10 to the power of 6 to 10 to the power of 5, what I'm doing is I'm making the power smaller, so my decimal point is going to have to move to the right. If the power gets smaller, the decimal point moves to the right. If I'm reducing it by 1, I just move the decimal 1 point to the right, 1 place to the right. If I was to reduce this by 2, I would move the decimal point 2 places to the right. If I was to reduce this by 3, I would move this 3 places to the right, and so on. So I end up with 9.4 times 10 to the power of 5. I can now cancel out the 10 to the power of 5 on both sides, and I'm left with A equal to 9.4. So I was asked to find the value of A, and A is equal to 9.4, which is a member of the real number set.